6,000. Now when you're working with fractions or with mixed numbers, then you have to look at the fractional part of it. So if the fractional part of that number is a half or greater, then the whole number you have increases by 1. And if it's less than a half, then the whole number you have stays the same. So for example, if I had the fraction 5/9 and I wanted to round that to the nearest whole number, well, I know that half of 9 is 4.5. 5 is greater than 4.5. So this is more than 1/2. 5/9 is more than 1/2. So rounded up to the nearest whole number would be the number 1. And then if I wanted to round 3 2/7 to the nearest whole number, I want to look at just the fractional part, 2/7. That's less than 1/2. So I'm just going to keep my whole number the same. And so this would round to 3. All right, so now the next part we're going to talk about is estimating with square roots. When you're estimating with square roots, you have to remember that non-perfect square numbers have irrational square roots. Remember, those are numbers that have decimals that don't repeat and continue on and 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 on forever. And so what we want to do is find a rational estimate for it. Remember, rational numbers are whole numbers, integers, negative numbers, fractions, decimals, and we're actually going to use decimals to try to approximate our square roots. And this process can get kind of tedious. I don't think you'll actually have to estimate a square root on the Ames exam, but it's good to know how you would do it if you needed to like organize a list of roots in order from smallest to biggest. So here's how you can estimate the value of a square root. If we want to find the value of the square root of 2 to the nearest tenth, well, the first thing I'm going to do is try to find the two perfect squares that are right around 2. So I start with 1. I know that the square root of 1 is 1, and I know that the next perfect square is 4, right? 2 is not a perfect square, 3 is not a perfect square, but 4 is a perfect square because 2 times 2 is 4. Or in other words, the square root of 4 is 2, right? So I know that the square root of 1 is 1, and the square root of 4 is 2. So that means that the square root of 2 has to be halfway in between 1 and 2. So now I take the number that's smack dab in the middle of 1 and 2, and that number is 1.5. And I square it because I want to see, well, is that going to be too big or too small? 1.5 squared is 2.25, right? So that means that the square root of 2 is less than 1.5. Now, I have to find a number on the other side. So since 1.5 was just a little bit too big, it wasn't exactly equal to 2, I'm going to try a number that's just a little bit smaller. So maybe the square root of 2 is equal to about 1.4. So I'm going to try 1.4. 1.4 squared is 1.4 times 1.4, and that's 1.96. And that's a little bit less than 2, right? And it's pretty darn close, actually. So I know that 1.4 is less than the square root of 2, and that's less than the square root of 1.5. So the square root of 2 is somewhere in between 1.4 and 1.5. So now, in order to figure out which way to round, because remember we were trying to round to the nearest tenth, to find which way to round, I'm going to go halfway in between 1.4 and 1.5 and look at 1.45 and see if it's bigger than the square root of 2 or smaller than the square root of 2. If it's bigger than the square root of 2, I would round down to 1.4. If it was smaller than the square root of 2, I would round up to 1.5. So we take 1.45 and multiply it by itself. 1.45 times 1.45 is 2.1025. You can trust me on that, or you can check my math, which you probably should because I make mistakes all the time. So then we get the square root of 2 is actually smaller than 2.1025. So that means that the square root of 2 has to be closer to 1.4. So if I was going to estimate it to the nearest tenth, it would be 1.4.